Millennium to power millennium. Good morning. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, April 4, 2022, 3:31 am, Monday. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज तारीख 4 अप्रैल 2022, 3:31 सुबह के और मंगल सोमवार। Talk is same as usual with similar titles. Titles are almost similar, and that is, as you can read, that real quality and coordination, engineering, project work, projects works designs, reliable engineers, power of communication, concrete specifications, and civil engineering, contracts, safety, health, environment, methods, disputed claims, parties, what we do. That is, what we do is something I try to replace. Previously it was what we have to do. Now, what we are. Now, what we do, I am changing our to do. So, there's nothing wrong. And before going further, let me tell you again, let me advise you, this is my email ID, Suraj, SURAJ _ ENGINEER, engineer, at yahoo.co.uk. This is my name board, and you can see what is written on this. And then there is certification of chartered engineer, certification of professional engineer, international professional engineer, and chartered engineer, fellow of Institution of Engineers, and that is this one. And of course it is quality file that I present regularly, and this is coordination file that moves along with quality, and it is international specifications for concrete, and this is particularly from Japan. My dear friends, these are updated files, and I have to discuss. I keep these two files now closed. Chartered engineer I close, fellow I close, so that less files are available on screen. And issue is quality. Issue is quality because I understand in quality reality. It's not simple quality in speech only, but quality that is witnessed, that is experienced, that is delivered, or that is achieved on works, whatever works we have, production work, or we have processing work, or we have construction work, or we have whatever other types of works. Works are works. It is very general term. It can be small work, it can be medium work, it can be, biggest work in size or whatever, top level, bottom level, whatever level, and for which coordination is very important. Even a student has to coordinate. Only then one can understand what is subject, what is issue, what is chapter, what is point of order, whatever you call it. And projects works, and projects means collection of hundreds of activities, collection of long period, days, you may say. Some project can be done in months, and some can be done in years, and some can be done in days. It depends on what sort of project is that. And designs is basis of project. Without designs, no project can be done. And design doesn't mean calculations only. This is actually, design means an idea, a contemplation that is automatically created in our minds and souls. And then we have to think of reliable engineers, means engineers who can really be called engineers, not just certifications, but real capacity of a person to deliver, to think, to contemplate, to deliver, to achieve. And that is reliable engineers who can be relied upon, who can be trusted that these people shall deliver to us what we have to receive, what we have to develop ourselves for. That development of society is done in physical form by engineers, and that those engineers belong to all branches of engineering. It's not civil engineering but all other branches, but civil engineering is branch number one. From that point of view, you have to understand power of communication. How do we communicate with each other? How do we communicate to ourselves? And then concrete specification I'm talking, which I just showed to that file. Concrete specification, and in fact those specifications otherwise also, if this not belong to concrete, there should be strong specifications, strength or potential specifications, you can say. It's not only concrete, but concrete not as a material, but concrete as a state of work. We can say, yeah, I'm a concrete person, you are a concrete, you have concrete idea, you have concrete basis, your talk is based on concrete consideration. That means a kind of solid, we say concrete. This design is concrete, my God, you have done perfect design. That's what, or you can say concrete is a kind of, we call, oh, it is very strong, it is Majboot. Likewise, civil engineering means engineering that helps civilians to move forward, or society. Civil here is a society, you can say community or society. Civil engineering means a society or community engineering. And contracts, of course, agreements between two persons or two parties to do something for some money or for some other reason. Consideration, we call that. Whatever sum is to be paid to a person who does something, so party to or contract, whether it is a written contract or it's not written contract, it's a verbal contract or promissory it is. And we can say, okay, this is contract, I am paying to you this much and you have to do this work for me. It's called contract. Consideration must be there in whatever form. That's this contract, very simple. Two parties must work for, and actually both are contractor. If you understand this point, one is contractor, whom we call employer, that has to pay to other party who has to do something, and that person has to receive money after doing that. That's called also really contractor. So in fact, on contract document, both have contracts. One has to make payment, other has to receive payment for work done. And then we can say safety, health, and in ergonomics, we can say safety, health, and environment. Safety, health is very important part of life, and even if you don't work, you have to remain safe, and that's point. It's top requirement. We have to consider first at all, because only safe people can work. Otherwise, you meet accidents. And then we have to see methods. Means what method we have to do? Method in designs, methods in construction, method in planning, methods to prepare contract documents or tender documents, or you can say technical and non-technical, contractual or non-contractual documents. It's a big job, contracts for projects. We have to be very specific in that method, what to do. Method of preparation of contract document itself is a big job. Means we have to know what we have to do, and that we know only for designs of documents or drawings or specifications, and a complete complete package of that project, whatever we have, irrespective of size of it. Sometimes we have to prepare everything. Say you have to construct one room, for that one room also you have to do same documentation as you do for a big project. Of course, sections are same, quantities may be different, but items may be same. We have to see that way. Means a lot of documents are required for doing something. So it's in profession, and people think only in professional context, but everywhere it should be done. And then we talk of contracts. Means of course claims become part of contract. There may be disputes, disputed claims there may be. And as we say, parties, we discussed already, contracting parties or other parties involved, extended parties or third parties, likewise as what we do when we have to think and what we have to do. That's the reason I try to explain this, because what we have to do, we have to understand that point. We have to meet these titles, what these titles, we have to work accordingly. And there's a set procedure also which cannot be defined so easily. Means process has to move from thinking stage or from conception, even pre-design stage we call it, from pre-design stage to design stage, or pre-design stage from before that also, pre stage, where we can say okay, we have a point in mind, we have a plan that we have to do this project. So that is stage of budgetary formation or policy decision, what you can call it, and then goes to pre-design stage, and then it further goes to design stage, and then it goes on to tendering stage or bid stage, and then going to bid stage and award stage, and contract or construction stage, or you can say design and construction stage, and then it goes to it goes to maintenance through commissioning. We have to complete that project, commission it, and then goes to maintenance. This is general procedure we have to do, and if we cannot say no, we cannot do it, and that's very important point. We have to understand this procedure is procedure, and we have to be very clear about that. And that's the reason I try explain all the time. You should remember that real quality and real coordination. Of course, we talk of coordination, level coordination, engineering projects. I want to explain every day something, because quality is not just we can understand one day. We have to experience that, and experience can be done only when you handle some project. But it's not everyone to handle projects so easily, because you must have, if you want to learn contracting, it takes time. It's indirectly, you can say, another branch of engineering, though it's not branches, but it's a part of engineering. And contracting is not easy, because it doesn't mean you're a contractor, you're a contractor. No, you cannot say that. Contract is of course a party, but engineer who devises contract, who designs contract, now must know engineering contracts, must know what is contract and what is related law, or what are related laws to this contract, how designs are done. Design also is a part of contract. Specifications writing is also a part of contract. And you can say so many points are involved in contract: workers relations, and you can say safety requirement, quality requirement, planning requirement, and engineering coordination requirement. So many topics. That's why when I say contract, means all these points which I included in title are very significant, without which we cannot do anything. And we cannot simply say this is not engineering or that is not engineering. All this is part of engineering, and that one we must understand. So my dear friend, don't be discouraged by that. What I'm saying, point of view is that we have to understand this, and if you understand this, we can do a lot. And that point we can say. That's why I always start with real quality and real coordination. Real quality means it is something that's overall, from pre-design stage to commissioning stage. You can say quality is involved, and same way when quality is involved, quality is based on real coordination. If you cannot coordinate, you cannot get quality. If you cannot coordinate, you cannot start a work. If you cannot coordinate, in fact, you cannot do anything. We will do foolishly if you do something without getting complete information. Drawing or procuring complete information is called coordination, to be very frank. You must know what is required. You have to find out from whatever source. That is your problem, how to get it, accumulate it at one place. And then it is to be transmitted also into action. We cannot simply say we have got complete information and automatically we shall get quality. That is not acceptable. We cannot get automatism in that. Even though I repeat same project, there would be different coordination requirements, and that coordination can be technical one, can be design one, can be engineering one, can be non-engineering one, can be marketing one. Long list can be prepared for that coordination, but there is no meaning, because people do not understand coordination, and that's my experience. To be very frank, I have to speak truly. I have to speak correctly what I experienced. Coordination is an art. Coordination is a science. Coordination is a system which is flexible for every activity. Which system? You have to devise, you have to think about that. How to, don't forget that there are so many softwares which are no use, means those are customized ones, but they say these are general. General software for coordination lies in your mind. You have to utilize that. Mind is mind. No one can say no. It's mind that is your teacher in coordination. It's mind that gives you contemplation, that gives you a scheme how to do it. And that scheme can also not be perfect if you don't have experience, if you don't have knowledge about that. I consider coordination is a domain as well as quality is a domain. Communication is a domain. Communication is not general everywhere. If you know I can communicate myself and I can coordinate, I don't accept that because somebody told me like that. When I raised this question in one meeting in Jeddah long back, I asked someone when the whole staff was available, engineers were available, I want a person who can do coordination. One young engineer came, I can do coordination. I was very impressed with this person, very interested in coordination. He must be knowing. I trusted that person for that. But when he did not do anything on that, I was very much upset. Means, why do you accept something which you do not know even? Means for them, coordination was just communication, information to send mail to someone, and that's it. No, that's not coordination. That is a clerical job. If I send mail to someone else, I think coordination is a part of coordination. It's not coordination. And this is a point. I was very upset with that person. I did not say anything because I knew that person was too young, experienced one. He just posed his personality. I can do it, but he did not do anything anyway. I'm not going to say. What I will say is coordination is a responsibility. Responsibility from each and every aspect. I'm not finding this caliber in young engineers and also in many senior engineers, I'm sorry to say. Also, I'm not finding this capability in many bureaucrats. I'm also not finding this capability in politicians. I'm not finding this capacity in medicos. You can say this word doesn't exist. You can experience yourself. You search on Google or whichever machine you want to search with. You try to find coordination. You will find very little or just theoretical that books tell. And that's not what we require. Books cannot tell us. It's material that is important. I don't want to see formula, this is process, that is no, process is not important. Process can be written by only those who have done it. And when people have not done it, what's the meaning of saying we know it? Not at all. So my dear friends, quality is technical of course, but coordination is not technical. Coordination is miscellaneous. It involves technical, it involves non-technical, it involves engineering, it involves non-engineering, it involves business or marketing. It involves everywhere. For an engineer who have experience in field, those engineers know what is coordination, but unfortunately it's very difficult to keep everything on record, and that's where we fail. If you don't record coordination impacts, coordination procedures, certainly we can say we are failure. We are failure there, and that failure is really not acceptable. I understand failure is not acceptable. Why should I accept something which can be done? My point of view is different. If I know what I have to do, means it is to be done. Why I should worry not to be done? Why not should be done? Why not? What's the question? If we are engineers, we know our responsibility, and we know without this problem solution, we cannot do that. So why it should not be done? And that's my point. We can't say we can skip it. How can you speak when it's required? It's a part of your work. It has to be done. But what to do, how to do, and that's the point. Coordination is a process of concentration. Without focal point, without focal length, you cannot coordinate. And coordinate means you should know. If you do not know, you should know what you have to do. A work has to be done. It can be small work, it may be big work. A work can be done. And there are problems on work. So why do we call there are problems? Because you have lot of losses in information. Information is not clear. Yes, you can raise questions to designers, you can raise questions to all others to know about what is fact, where is missing, and that's also a part of coordination. Coordination applies everywhere. It applies everywhere from beginning of a project, whatever project, whole project. You can say designs, construction, maintenance also. In many cases, so we can say coordination is a word for which there are no books. In fact, even if there are books, those are not specific books, just general one. And I tried many times to get more and more information from internet, but such responsible information is not available on internet, and that's really, you can say, poor state, I can say. This clearly indicate the people's interest doesn't lie in coordination, and that's reason because people are talkative nowadays. Talkative or telephonically oriented, mobile oriented. People have lost their capacity of writing, capacity of recording. They think just to speak something, it will be done. That's not enough. You cannot simply say, I told you to do it, you did not do it. That's not professional question and professional answer. I told you to do it, you did do it. You are at fault. No, you are at fault. Your job is not telling only. Your job is providing information. Your job is to equip that person which is required. You should know what is required. Why should that person tell you? If you do not know, you are not capable of instructing that person, even if that's junior to you. If you are a site engineer, you're a project engineer, or you're a designer, and you cannot say you should not do this. Did you tell him on the time? The question is that, did you tell this somewhere? Did you tell on drawings or in designs or in specifications or somewhere? You did not do that. Why? Because you did not like you imagined this should be done automatically. And that imagination, pertinent automation, does not help everybody. That's why we can't do right work and we can't say it's quality work. Sometimes people don't even understand what's quality requirement. And they also don't understand what's coordination. What's all coordination? People don't know. Okay, terminology can be coordination or it can be something else also. I don't say no, it can be, but question is, process is same. If I don't have complete information, whose fault it is? I can't say it's my brother's fault, sister's fault, it's my fault. Because I'm qualified for that, I'm expected that one. Of course, I did not pass coordination subject, there's no subject at all. I did not pass communication subject, but whatever it is, these subjects are not possible because if you work successfully, you have to use all these activities. And that's why I say real quality, real coordination, very important factors, very important requirements for every work we do. Whatever work you do, even you cook in your home, coordination is required in cooking as well, sequence is required, complete setup is required. You should know what time, what activities take. That's important, though that's not formal one. But because of your experience in cooking, you can do that. I'm just giving an example, nothing else. You may do cooking, you may do something else, you may you may be a teacher for that, but you should know what you have to teach, what is subject to start in this. So we can say we should not sleep on this. Why should we sleep in the right? And sleeping means we ignore it or we don't think of that. That is not sleep. Sleep doesn't mean going to bed and taking rest. That's what I'm saying. Actually, it's not who am I to say. What I'm saying is that stop sleeping. At least I'm talking of my country, though it's meant for whole world. I don't like talking too much on phones. You have to communicate properly. And of course, this is electronic world, this is a digital world, but this word does not stop me from keeping all records with me. If I keep all records with me, we can find immediately that reference and we can find action on that reference. And that's point where coordination, when you say recording is a part of coordination, because if your records of all movements, all activities, you can pinpoint that and find what action was taken on that, which doesn't happen really these days. And that's why I'm stressing on starting and improving quality and coordination status. And it applies to whole world. I'm saying I have not seen many expert people in coordination. Coordination is very important in development works, in engineering works. It's very, very important. And if we don't do that, believe me, we lose a lot. Even at school level, we should teach what is coordination, what is quality. People otherwise take different meanings, undue meanings, irrelevant meanings. And that's what I say. Everyone should stop sleeping. We should think on. Thinking is free of cost. Don't you understand this? Thinking is free of cost. Analysis is free of cost. And finding solution is free of cost. And if you make up yourself fit for this, suitable for this, well, I think you can go to whatever levels based on your experience, your test, your examination, your qualification, your education, whatever you have, your CV shall become more and more specific. And that's where you can say, once you develop habit of making good communication and then doing good coordination, you shall rise up in your field in whatever you are, because you have a capacity to question or seek clarification or give clarification, whatever it is, and you become an authority in that case, an authority. Quality and coordinations, you can say, I can't say be my friends, I have to be his friend, even if this quality and coordination doesn't like, but it has to be my friend. It depends on me how I do it, because it's important. And I and others cannot satisfy work in profession without both domains. And then other domains are technical one. Those those are known because we studied them. We neither studied coordination nor we practice it, and that's where failure occurs. And it's not engineering alone, I can say. It's an every profession or occupation that coordination is not affected. People have stopped thinking about coordination in digital world. Why they think it's necessary? We can use software and find. And this misconception this misconception stays in mind of everyone, and that's not acceptable. Life cannot move on in conception, bad conception. It has to move on reality, and that reality is important. We have two domains. Now we have quality one and coordination other domain, and we have to respect these domains. Quality we have to achieve, and how to achieve it, we have to achieve it based on facts, based on criteria that we consider it's important for this. That's why I say coordination is very important part of profession, and not only is good in profession, it's requirement in profession, it's requirement in life also. And I don't want to bore you just for giving useless examples. Coordination is required in your daily life, it's required in your safety, it's required in your health, it's required everywhere. Your body has to coordinate properly physically as well as mentally. And if my body doesn't work mentally and physically in a sound state, I fell sick, or we start thinking depressed. Why people are depressed these days? Why stresses, even though they don't work a lot physically? Because they are not physically coordinated. Their parts do not coordinate. There are so many reasons for that. People keep off nature, you know that. People keep off natural power, and that's responsible for this to much extent. I can simply say we should not keep off this power. We have to be with this power. We have to keep ourselves intact with natural forces. We have to digest those forces. We have to understand those forces, and that's where it's useful. And that's our, I say, we are all friends together for all others. We are friends, you can say. We are friends together for all others. Demanded quality, you cannot leave. क्या हो रहा है? हाँ तो नीचे सोया कपड़े में। Demanded we all are friends together for all others. Demanded quality. You cannot leave me because you are my destiny and nation's destiny as well, and that's what I consider plainly for me. I consider this professionally for me, and you have to do it for yourself because you have to involve yourself on works. It's very important point. Engineers can handle you both, and they should do it. Those engineers who are not very well experienced, particularly budding engineers, it is their job to involve even if they do not like it. You see, you studied engineering subjects, many subjects are related to each other. Like designs are related to theory of structure related to applied mechanics related to strength of material, and strength of material is related to materials, and materials are related to earth. You got this point? Designs, we say, designs are related to drawings are related to specifications, specifications are related to standards are related to, you know, codes, and codes are related to work experience, and work experience related to works. You can form train of sequences. It's not that trains of sequences work only in plants, facilities, projects. This works in our life. This works in our life as well. And really speaking, this is very important point. We should not take it easily. It is important and important and important. And just like we can say, civil engineering is related to mechanical engineering, and mechanical engineering is related to civil engineering. Civil engineering is related to mechanical electrical engineering, and mechanical electrical engineering is related to manufacturing engineering, and manufacturing engineering is related to materials engineering. And likewise, you can say nothing is independent. No profession is independent. We have to be with us. We have to be with profession. It's same thing, just like we have social relations, we have professional relations, and that's why we are taught different subjects. I learned being a civil engineering student, I learned mechanical engineering, I learned thermodynamics, I learned electrical elementary engineering, and likewise we learned social sciences, sociology, economics, civics. We learned, all these despite being a student of engineering, in diploma, in degree. We had to study such subjects, though these subjects are not related in profession, but these are required in society. How to handle society is very important. How to handle people is very important. So we can say nobody may do it, but engineers can handle these domains. This is communication domain, or you can say quality domain and coordination domain. Whatever domains are there, engineers have enough potential, enough knowledge, enough qualification to conduct these domains. There's nothing wrong with that. It's easy one. Only we have to take interest. And interest is our answer. If we don't take interest, we cannot do anything. And that point we have to think about. What is said is we require to establish both domains permanently in engineering professions and also other walks of life. have active quality performing in applications, quality in SHE sufficiently, can say. We can therefore say real quality, real quality engineering and reliable coordination engineering. What is real quality engineering? We have to understand this point. Means whatever comes in mind, I doesn't mind I have written somewhere. Real quality engineering means the reality of world, reality. It's not theory alone. It's not thesis. It's not imagination. And reality means the facts. Really means what exists. Engineering world means the whole world, universe. I consider what engineering we do is very small. Whatever engineering we conduct on earth is very, very small. So we claim we do it, but it's very, you can say it's minute part of what is universe engineering. If you ever think of its duty, our job to think, scientists must think, engineers must think. But do we do really? And that's point. We are talking of quality engineering on Earth. Because I can't talk about other planets, I'm talking here. And this engineering which we do, already we are doing this on a platform, and that platform is Earth. If we consider Earth as platform, because we don't have any other platform, we can't stand in air. We can stand on continental or solid part, and that's my question is, if I ask myself, I am so concerned about construction engineering, design engineering, do we ever think about earth engineering? Who designed earth and who constructed earth? Can you think of? Maybe you say this is not your subject. I talk. Yes, it's not my subject. I'm not earth engineer, but we are living on earth. How we are living on earth? Because earth is available. It has lithosphere, it has aerosphere, it has relation to solar system. This means there is something that has weight, that has potential, which we have to understand. And that's what I will say. First engineering is universe. First engineering universe. Of course, every human being is a product of engineering, of God engineering, which we do not know. It's beyond our contemplation. Is beyond our thinking about human engineering, human production engineering, human not only production engineering but human building up engineering. Every human is built up, every creature, every animal, every insect, all these are built up. They have certain spans of life defined by that designer, that thinker who thinks for entire universes. All universes, all Brahman, you can say. When I say I'm resting on earth, I'm using earth, this means earth is my foundation, earth is my ground, right? Of course, earth is ground for everything. Even we design foundations, we consider properties of earth at that portion, that point. That's why I say we have to understand this building of earth, this building we name earth. And earth is one part of that scenario. There are many other parts like earth in this system, which we name solar system formally, though there is no exact location of all these. We don't know how does system work, but we only observe, and science observe this. And whatever we can observe, we can say yes, we have this value, we have this understanding, and we do it. Don't feel bored, please. I'm not talking in a boring way. I'm talking in a real way. That system is system, and we have to understand that. So who is that designer? I'm just looking for, I want to see that designer, but I could not find that designer till now. I'm looking for that designer who did not sign art, but whose work is very strong. There is no requirement of signature. Earth has been there. We cannot even imagine. We can design buildings for few years, few decades, and we can develop other projects, other products for a couple of years use only. Then we disregard them. But this product of Earth and this product solar system has been there, which we do not know how many years since when it was spent. And we don't have any calendar also just to let us know when it started. All referral calendars we have, all referral, nothing else. That's why I say, if you understand this, being an engineer and those who are scientists, being scientists, they have to think about this. Where is that design? I want to see that. Product is available, its design is not available, its method statement for doing is not available. Who is that secret power who, who did all this? And of course, we can't find source from there. This might have come to this location, how this earth was constructed, how other planets were constructed, who constructed them, and from where was energy just imaginarily used and converted to this soil or this earth or continental part or solid part. How did we do it? And that's the point we have to be very careful about. If you understand that point, I think we can solve every problem, but we cannot do that. And that's really interesting. We all worship, we all believe in some religion, we all believe in some faith, but I don't believe in belief. See, we have to be logical. Religions are only imaginations, though it's not part of my talk, but I'm just trying to refer. No religion is justified, no religion can be scientifically evidenced, nothing can be proved. When human comes or other creature comes to earth, we come without any certification, we come without any identity, even name is not given, only a small piece of body is given, which is to be developed by nature as well as by those who are responsible for it, mother and father. That's what I say. Facts cannot be known. We have to know these facts. If I know who is designer of earth or who is designer of my body, then I can be successful. But we can never know. We have not known yet. But there is some power. And we have to coordinate with that power. We have to communicate with that power, which is still not possible. Possibles are ways, indirect sceneries are available, but facts remains. Facts which are applicable are not known. And when facts are not known, we cannot say it engineering, because engineering is based on physical facts, not soul facts, physical facts, or you can say body facts. This is what is engineering. We believe in engineering. I don't say we believe in engineering. I should say we logically accept. We do it logically. There is no belief, no question of belief in engineering. Engineering is based on facts, and when facts work, you cannot say this is belief. Facts do not work in sentiments, facts do not work in faith. That's why we say this is faith. It's not piece of fact. There is a difference between facts and non-facts. When you can't know something, you can't answer something, you can't do anything on that, you simply say, okay, we believe it. And there's then a question of dispute between belief and between non-belief. Believing is something because you don't have any answer or you don't have access to facts. But facts are not belief, because facts are seen, facts are known. And that's what I say. It is only referral name that we give. Only these are referral names of people who use religion. Same way, belief is it's not factual, it's just referral. But life is not referral. Life is a fact. Birth is a fact. Death is a fact. And death is well engineered in that case because it's based on fact. Birth is based on fact. That's why it's well engineered. So we can say process of human construction is engineering, and process of human leaving this body is also engineering. At that point we have to understand without any aid of book, because I don't want to depend upon very small book of A4 size or less. I want to see this billions of kilometer diameter book, which we can say it is solar system. How does it work? Why does it not fail? That's the point of concern. We do not know about that. Why this system does not fail? Can it fail? I always raise this question to everyone. God has made this universe with different orbital sizes, with different planetary sizes, with different planetary system or planetary properties and characteristics. How it is possible? If we are so strong, we say we are so strong. Everywhere, every country claims something. I am superpower, I am this and I am that. Can we? Can we make, forget solar system, can we make one small earth? It's my point. Can we make one small earth? This earth is around 12,500 diameter, kilometer diameter. Okay, you cannot make that one. Can you make 1 kilometer diameter earth? 1 kilometer diameter sphere. Can you make it? Can we make it and install in solar system? Answer is no. Never, never, never. Okay, if you cannot install a solar system, can you make earth like this and make it move in the universe? You cannot do that. This means we have no capacity. Frankly speaking, we have no capacity. These are very small capacities. When we claim I am engineer, I am doctor, I am engineer because of engineering, and engineering exists because of resources, so natural resources. Civil engineering particularly cannot depend on finished materials. We we finish materials ourselves. We construct ourselves. We study subjects ourselves. We study materials ourselves. We study everything that comes in our way. On way we meet so many addresses and we do that. And that's what I say. Real quality engineering and real coordination engineering are distant from us. How can I know quality when I don't know system? When I don't know anything? At that point I have to say reliable coordination engineering, and this is very vast thought. Reliable coordination engineering. This means we have to coordinate from within ourselves. We have to coordinate available information. We have to link the information, and we have to find compounding information, not simply information but compounding information, or you can say first a mix of information. That's where we say that okay, fine, we have done this. It's really very informative. We can say we can move like that from this point to that point, and that point is really interesting one, we can say. So what my talk is all about is something very, very different. I have to consider this point seriously. And coordination engineering, I can say reliable coordination engineering projects, public and engineers say this. It's for everybody to understand, know this. And it's not that simply I'm telling you something very specific. It's very general that missing real coordination means missing good engineering. And we are bound at least to do minimum engineering, if not maximum. And we now go to concrete specifications. And concrete specifications, what's happening to this file? It's not opening. Concrete specification, and let's say here, as the files are hung up sometimes, and that's why it takes time to open it. Why it's not opening, I don't know. What's the reason behind that? Secured. What's happening to this? Something wrong somewhere. Perf is not performing. Why? So this is standard specification I'm looking for, and I'll reach page 150 on this now. So that ready mix concrete we discussing last time, ready mix concrete, and we discussed in a fruitful way, and we said that okay, mix concrete we have to go through, and it is selection of plants, and we have to study about specifications of quality. So let's go to 150 page. Next will be talked of this general rule. The ready-mix concrete used so should be one that conforms to whatever. So ready-mix concrete specifies requirements as type. Okay, we go to ready-mix concrete. Let's start somewhere here. Selection of plant. I'm just overlapping last time. Selection of plants. Ready-mix concrete plants shall be selected from whatever is listed in local areas in any country, whatever you can say, preferably from plants that have been permitted by whatever controls. You can say inspectors have inspected these. If other plants need be selected, a certified chief concrete engineer, or I can say material engineer, concrete engineer, or equally knowledgeable and experienced engineer be permanently posted, and plants shall be selected from those capable of performing mixed design and quality appropriately. Matters to be considered for selection of concrete plants shall include transportation. We can say matters to be considered for selection of concrete plants include the transportation time to site, that's very important point, and unloading time, concrete production capacity, number of transporting vehicles, manufacturing equipment, conditions of quality control, and so on. Ready-mix concrete plants vary widely in terms of production facilities, production technology, quality controls requirements, and that's what we say. This is very important item under industrial acts. With number of certified plants as it is that their whole situations, the specific general rule says this. In view of this situation, this specification requires as a general rule that ready-mix concrete plants be selected from. Okay, that's a file list. That's okay, go on. I don't want to waste time. Let's say specification of qualities. When certified ready-mix concrete is purchased, type of ready-mix concrete and other necessary specification items be specified so that concrete of required quality can be obtained. This means specification we have to give ourselves. We don't expect that whatever we want we have to specify, and that specification should work. We have to get that one. This means we can say type of ready-mix concrete. Type of ready-mix concrete shall be specified on basis of minimum size of aggregate, that is coarse aggregate, normal strength, target slump flow, and unloading location and type of cement in view of requirements for fresh concrete such as filling ability or pour ability, segregation resistance, and changes in quality during transportation and during the process from unloading to placement. Specification items, type of cement, you know well what is meaning of that type of cement, type of aggregate, maximum size of coarse aggregate, and method of alkali silica reaction as age of nominal strength guarantee, upper limit of water cement material ratio, and water content, upper or lower limit of cement content and air content shall be specified through consultations with producer on an as required basis in view of in view of such factors as specified strength, age, durability, and cracking resistance. I repeat, this has some weight. Formation it has, type of cement we have to consider, type of coarse aggregate we have to consider, maximum size of coarse aggregate, and method of controlling alkali silica reaction must be there, must be given, must be explained, and it should be through consultation with concrete producer, manufacturer, whatever. Details such as nominal strength at what age, it should be guaranteed. Upper limits, what are upper limits of water cementitious material ratio, and water content, upper or lower limit of cement content, and air content. Air content be specified through consultations with producer or as needed basis in view of such factors as specified strength, age, durability, and cracking resistance. We have to be very specific about these parameters, because these parameters will tell us what we are doing, what we should do. And when the remix is ordered, we have to provide what strength we require for delivery, or you can say what grade of concrete we have a requirement of, what is value of slump at site, what's value of slump at batching plant, and what is value of slump elsewhere we are going to use intermittently. It may be much more at batching plant, and it goes on reducing on road journey, and wherever on site it reaches, it may be further down, and when we place in position using pump or crane, at that time it will really stiff as every starting from your plant. It goes on gradually increasing in its stiffness, and of course at site it will be much less. At that point we have to consider means from maybe its liquid state on batching plant or near that liquid, then it goes on evaporating that liquid later on. So what commentary we have here? Types of ready mix concrete are determined by combination of specification, namely type of concrete, maximum size of coarse aggregate, target slump or target slump flow at unloading location. Nominal strength type of ready mix concrete must be selected from respective combinations, so that concrete of quality specified in here can be obtained in this specification. Lightweight concrete and high strength concrete are dealt with. Lightweight aggregate concrete and high strength concrete of part regarding special concrete. Keep in mind that for high strength concrete, for example, specified strengths ranging from 60 Newton per millimeter square to 100 Newton per meter square are considered, and specifications regarding slump flow, air content, etc. do not necessarily the same as in specifications. Type of type of ready mix concrete. In this aspects, normal concrete, lightweight concrete, high strength concrete. So we have normal strength of concrete, then we have lightweight itself and high strength concrete. So this column is a type of concrete. First one, types of concrete, that is here type of concrete, and it is maximum size of coarse aggregate, slump or slump flow here centimeters, and nominal strength 18, 21, 24, 27, 30, 33, 36, 40, 42, 45, 50, 55, 60 likewise. This is a nominal strength in newtons per millimeter square. So we have to start thinking like this: ordinary concrete, lightweight concrete, high strength concrete. Concretes are given here. In say ordinary concrete, maximum size of course aggregate is indicated 20.20 mm or 25 mm. It may be 40 also in some cases where section is large, and lightweight concrete is 15 newtons. This ordinary and lightweight concrete is 15 newton, whereas high strength concrete may be 20 and 25. So 15 mm, we have four dimensions here, sizes here: 20 mm, 25 mm, 40 mm, 15 mm, 20 mm, 25 mm. So major are 20 and 25, and maybe few cases 40. This point we have to gather in this reflected analysis. We have to consider slump as well. It says slump in centimeter, though it's a millimeter, doesn't matter. It's giving 8, 80, 100, 120, 150, 80, 80, 180. So either it's 8 centimeter, 10 centimeter, 12 centimeter, 15 centimeter, 18 centimeter. It may also be 21. And that's in that case 40. When we are saying 40, it is 5, 8, 10, 12, 15. Means 50, 80, 100, 120, 150 mm. And also in case of lightweight concrete, where 15 mm aggregate we allow, it is 80, 100, 120, 150, 180, 210 mm slump. And then also it is when high strength concrete, it is 20, 25 mm, and you can say slump is 10 or 100 mm, 50, 150 mm, and 180 mm. It's also 50, 500, 15, 60. I don't know why it's that. This flow. We can say nominal strength. Nominal strength are given here in terms of O, and where it's not. In ordinary concrete starts with 18. It can be done with 18 Newton, 21 Newton, 24 Newton, 27 on to 45 Newton. 45 Newton, and above that it's not ordinary concrete. In 40 also same straight lines, but there is no you can say 21 grade, 21 centimeter to 110. No 18 mm is used, so 21 onwards to 45. And we can say also in lightweight concrete, that is 15 Newton, we have all range up to 40 mm, not above that. 40 strength Newton I can say. And then high strength concrete, it works only in range of 50, 50, or you can say 50, 55, 60. It's not considered below that. High strength concrete you cannot do, because up to 45 Newton we don't consider hard high strength. 50 and above is considered high strength concrete. So we say that specification gives the standard values of minimum slump for placement in section. Target slump at unloading location requires be selected in view of changes in and tolerance for slump expected to occur until concrete is placed. First says target slump of unloading location. Unloading location requires to be selected in view of changes in and tolerance for slump expected to occur until concrete is placed. The specification refers to concrete with slump of 21 cm and slump flows of 50 centimeters, 60 centimeters. But materials and construction, construction standards of this specification do not assume use of those kinds of concrete. Quality of those concretes must be determined in accordance with materials and construction standard specification before uses. Strength requirements are often indicated in terms of specified strength, nominal strength, which is a term used for distinction from specified strength used in specification. It's a dimensionless number indicating strength guarantee under conditions. Now we say in materials and construction standard target strength for mixed proportions is determined so as to satisfy condition that probability that test value set forth in section becomes 5% or less. On the other hand, target strength is determined so as to satisfy percent strength that is demanded is larger than that by standard. In this way, by regarding specified strength of concrete as nominal strength, probability that strength of ready-mix concrete becomes lower than specified strength can be made to remain at or below probability specified. Here is a graph, you can say coefficient of variance, that is V, and here is over design factor. This is coefficient of variance. A is comparison of over design factors, that one, and there are so many points in that. You can see here this is 0 to 20, this is percentage variation, and here is over design factor that comes to 1 maybe the gap of 0.1, 1.1, 1.3, 4, 5, and 1.6. We have here conditions and conditions in different conditions. This is condition in this article, this condition is the article, and that is its condition other one. Now number one here is over design factor condition, that is in 1, you can say here wild 1, wild 2, and wild 3. Over design factor, that is what do we call it, these points, I think is wild, right? Wild, okay. Over design factor is here, if we consider over design factor is how much? 0.85 divided by 1 minus 3 V, 1 minus 3 V coefficient of variation, and that is equal to 100. We get over design factor, and over design factor we make it, let us say how it is calculated. V is, let us leave is 5 for example. We take V is 0, let us say. If V is 0, this means this is only 1. Means if we take V as 0, in that case it is 1 minus 3 below minus 2, and I think 0.85, how does no, V can't be 0. Let's say 5. Let us say V is 5. 3 into 5, 15. So 1 minus 15 over 100 means 1 minus 0.15. So if you take V as 0, we take 0.85 over 1. So that is 0.85%, 85% you can say, 0.85. So if 1 is 100, let's say factor 10. If you take 10, then 1 minus 3 into 10. 1 minus 3 into 30 means 0.3, 1 minus 0.3 is 0.7. So 0.85 over 0.7. We can get more than 1. So that's what it says. This way we can calculate this over design factor. Same way we can say in number 2, this was number 1. Here is this, and here it is also over design factor number 2. While number 2 here in this zone is 1 over 1 minus under root 3 V under. So this is again variable, it's lesser because under root 3 there was 3 above. This means it over design factor would increase here, and I think decrease or increase. Let us say case of 5, it's 1 over 1 minus under root 3 into 5. Under root 3 into 5, let's say 5. So 1.13 to find 1.3.3. So this same way number 3 is probability of test value of compressive strength of concrete being lower than characteristics compressive strength 5% or less. Probability of test value of compressive strength of concrete being lower than characteristic compressive strength is 5% or less. This graph is indicating about over design factor and probability of test value of compressive strength of concrete being lower than characteristic compressive strength of 5% or less. Comparison of what is in factor. Now what it says, this box allows item A to D and on and as required basis item E to Q specified strength of specified strength through consultation with producers is required. However, that item is be specified with a range A to H up to here. A to H. Let us see what's that. Then be specified, and even if specifying types is not enough, concrete of required quality can be obtained by specifying necessary items among these items. And what is that? Type of cement. This is what we have to mention. That's a must. We cannot say no. So it is type of cement, type of aggregate, maximum size of coarse aggregate, and alkali silica reaction control method, classification of aggregate by alkali silica reactivities, that is classification of aggregate by alkali silica reactivity, classification of water, type and quantity of mineral admixture, upper limit of chloride content if different from standard upper limit, age at which nominal strength is guaranteed, air content if different from standard air content, unit mass of concrete in case of lightweight concrete, highest or lowest temperature of concrete, upper limit of water cementitious material ratio, and upper limit of water content, lower limit or upper limit of cement content, amount of increase in slump from that of ready mix concrete before fluidization, other necessary items. So in that we say A to H. Says we can say A to H. It's however A to H. A is type of cement, B is type of aggregate, C is the maximum size of coarse aggregate, D is alkali silica reaction control method, E is classification of aggregate by alkali silica reaction reactivity, F is classification of water, G is type and quantity of mineral admixture, and H is upper limit chloride content. This is what it says A to H, and it says it's required however that item A to H be specified within ranges. So these must be ranges must be specified. And age at which nominal strength is required, air content, mass is so different. So let's go to, since the specified strength of concrete is usually indicated in terms of 28-day strength, nominal strength is also based on measured value at age of 28 days. In case, however, of concrete that requires a high initial strength and is made by using high early strength, cement such as pre-stressed concrete, or in case of mass concrete made says in case however of concrete that requires high initial strength and is made by using high early strength concrete, early strength cement such as pre-stressed concrete, or in case of mass concrete made by using low heat cement, it may be necessary to use an age other than 28 days as reference age for specified strength of concrete and secure required strength at that age. In such cases, reference age for specified strength must be given at age at which nominal strength is guaranteed. In case where upper limit of water cementitious material ratio required to be controlled, in case where upper limit of water cementitious material ratio required to be controlled in order to secure durability, water tightness. First is durability, then water tightness, chemical resistance, etc. of concrete limit value must be specified. Standard air content in these specifications are 4 to 7%. That is, generally defined. That is, what we say that standard air contents in this document are 4 to 7% depending on maximum size of coarse aggregate. Standard value may be 4.5% for normal concrete and high strength concrete, that is, and 5% for lightweight concrete. So 4.5% for normal concrete and high strength concrete and 5% for lightweight concrete. If your content is to be made higher than this value in order to enhance freeze thaw resistance, value must be specified. In construction, special concrete and specification of air content of high strength concrete specified for freeze thaw resistance. As stipulated in section, cement content is usually determined from water cementitious material ratio and water content in cases, however, where cement content requires to be reduced for purpose of thermal cracking control. In cases where cement content requires to be reduced for purpose of thermal cracking control, or where type of cement or concrete temperature requires special consideration, it's necessary to specify upper limit of cement content, type of cement or concrete, temperature through consultation with producers. If place ability determines the lower limit of cement content, mixed design cement content must be specified through consultation. In order to prevent alkali silica reaction of aggregate, it's necessary to take some of the alkali silica reaction control measures. Stipulated alkali silica reaction control method must be specified through consultation with producers. Measures to control total alkali content of concrete and control measures using blended cement or other materials that are effective in controlling alkali silica reaction. Control measures using aggregate that is defined safe. Now we have receiving what it says. It is receiving. For smooth placement of concrete, consultation we held with manufacturer producer and details such as delivery date, types and quantity of ready mix, unloading location and rate of delivery shall be determined. Planning and management organization shall be performed so that transportation vehicles do not stay long at construction site. Good communication with producer shall be maintained even during placement of concrete, so that placement work is not interrupted. Unloading shall be done at location where transportation vehicle can safely and smoothly enter, exit, and unloading work can be performed easily. Says unloading shall be done at a location where transportation vehicle can safely and smoothly enter and exit, and unloading work can be performed easily. Unloading shall be done by a method that minimizes segregation of concrete materials. Unloading shall be done by a method that minimizes segregation of concrete materials. Receiving inspections of ready-mix concrete. Receiving inspections of ready-mix concrete shall be conducted in accordance with materials and construction inspection standards. Now, in many cases, ready-mix concrete plants are considerably distant from construction sites. In order to carry out placement of concrete per plan, it's very important to discuss arrangements in detail with producer or operator of plant operator, taking into consideration such factors as production capacity of plant, transportation capacity, transportation time, receiving facilities, whatever facilities on site we have, placing rate, waiting time, and their whatever respective possible changes. With respect to transportation, requires with respect to transportation time, it requires that transportation be carried out so that unloading can be done within 1.5 hours after mixing is started. This point, however, requires a standard method that process from mixing to concrete placement be completed within 2 hours when outdoor air temperature is 25 degrees Celsius or lower, and 1.5 hours when it is higher than 25 degrees Celsius. 2 hours within limits of 25 degrees Celsius, and it is 1.5 hours when temperature rises higher than 25 degrees Celsius. In view of unpredictable circumstances such as traffic regulation, traffic congestion, and emergencies on transportation routes, it shall be difficult to complete concrete construction within those spaces of time when outdoor air temperature is high, unless effort is made to complete transportation to construction site in 1 hour. It is important for constructor to select a plant with a short transportation time. Keep an eye on time dependent changes in concrete. Draw up a plan so as not to keep truck agitators that have arrived at job site waiting long, and perform time organization management by keeping in close contact with operator. It's important to take measures in advance. It's important to take measures in advance, such as organizing construction site, securing access roads for transportation vehicles, and deploying traffic control personnel to guide transportation vehicles to unloading location approximately, so that transportation vehicles can safely and smoothly arrive and leave concrete unloading location and perform loading task easily. If concrete is to be plasticized on site, by using a truck agitator, it's necessary to discuss procedure in detail. If concrete is to be plasticized on site by using a truck agitator, it's necessary to discuss procedure in detail with manufacturer or producer and person in charge of plasticization, in due considerations of transport capacity in case where load capacity of agitator is reduced in view of agitating performance. Transport time is time of base concrete, receiving facility, the rate of placement. The transportation vehicles used must be one that minimizes segregation of concrete. Segregation of concrete is minimized during unloading cases. In case of ready-mix concrete, causes problems seldom arise because truck agitators that have passed a performance test are used. Ready-mix concrete that is found to have undergone a segregation, even if slightly, at initial stage of discharge from a truck to agitator, should be agitated for a short period of time at high speed in agitator before unloading. In case of high viscosity concrete, however, high speed agitation may cause air entrainment. In case of high viscous concrete, high speed agitation can cause air entrainment. In such cases, preventive measures such as reducing rotation speed need be taken care of. Transportation, placement, compaction and finishing. Transportation, placement and finishing tasks shall be determined so as to satisfy required quality of concrete structures, specifying each methods in details. Transportation, placement and compaction and finishing be performed by methods that make it possible to obtain required quality of concrete. So what it says, transportation, placement and finishing tasks shall be determined so as to satisfy required quality of concrete structures by specifying each methods in details. Transportation, placement, compaction and finishing shall be performed by methods that make it possible to obtain required quality of concrete. Construction plan drawn up prior to commencement. Construction plan drawn up prior to commencement of construction. Work outlines each construction task to be carried out with reference to similar types of construction work carried out in past. In course of construction work, in course of construction work, content of construction work may deviate from construction plan or methods better than planned methods may be found. Before starting transportation, placement and finishing tasks, therefore, it is necessary to discuss details with people who would be engaged in those tasks to find better methods. It's also important to double check content of not only construction plan but also design drawings and specifications. For example, it is of course necessary to install formwork and perform reinforcement and joint construction just as designed. It's also necessary, however, to double check whether there exists any area where placement of compaction of concrete is difficult to carry out by comparing design drawings and specifications with actual state of concrete construction. If such pre-construction studies and preparation or preparatory measures are inadequate, possibility of occurrence of defects during after construction increases. If such pre-construction studies and preparatory measures are inadequate, possibility of occurrence of defects during or after construction increases. Changes from initial construction plan may affect overall construction schedule, cause structural if such pre-construction studies and preparatory measures with actual state of construction if such pre-construction studies and preparatory measures are inadequate, possibility of occurrence of defects during or after construction increases. Changes from initial construction plan may affect overall construction schedule, cause structural design problems that can be predicted by constructor or affect contracts or other arrangements with local community such as traffic regulation, noise and vibration control, environmental measures. Both owner and designer therefore must participate in discussions and take appropriate measures. Major considerations are summarized. Schedule for concreting work. Now we have concrete schedule. So these are few points only. Not any complications here. Major considerations are summarized. Concrete schedule. Concrete schedule. What does it say? Is 21 Celsius reduced from 23 is 21 degrees. Wind gust is 12 kilometer per hour and hour. Humidity is 20%. Indoor humidity is 20% dry. Day temperature expected 41 kilometer. Yeah, this is what I just try to see solution now, just to make myself comfortable. Concreting schedule. Schedule for concrete work should be determined taking into account various factors such as type and shape of structure. Type and shape of structure to be constructed. Relationship with other construction tasks in overall construction schedule. Total quantity of concrete, method of obtaining concrete, quantity of concrete that can be obtained at a time, difficulty level of construction, influence on previously placed concrete, season. Any points? Where to see? So many points are here. Again, I say, schedule for concrete work should be determined taking into account various factors such as type and shape of structure to be constructed. That's an important point. Relationship with other construction tasks in overall construction schedule. Total quantity of concrete, method of obtaining concrete, quantity of concrete that can be obtained at a time, difficulty level of construction, influence on previously placed concrete rather than this new. So we can say schedule for concreting work should be determined taking into account various factors such as type and shape of structure to be constructed, relations with other construction tasks in relation to overall construction schedule, total quantity of concrete, method of obtaining concrete, quantity of concrete that can be obtained at a time, difficulty level of construction, influence on previously placed concrete, season and weather. Equipment and personal deployment for transportation, placement and finishing. What do you say about that? Equipment and personal deployment of transportation, placement and finishing. Type, model, capacity and number of equipment necessary for transportation, placement and other tasks. And personal deployment. So we have this, very important point, equipment, personal deployment for transportation, placement and finishing. Type, model, capacity and number of equipment necessary for transportation, placement and other tasks and personal deployment should be determined in view of such factors and other tasks, and personal deployment should be determined. Here, type, model, capacity, number of equipment necessary for transportation, placement and other tasks, and personal deployment should be determined in view of such factors as conditions at construction site, type and shape of structure, transportation, distance, concreting block size and a quantity of concrete to be placed, order of placing, rate of placing, ability of concrete, compaction, capacity, materials used, and mixes in quantity. Now you have to take it further. Where see we have to determine view of such factors as conditions of construction site, type and shape of structure, transportation distance, concreting block size, quantity of concrete to be placed, order of placing, rate of placing, availability of concrete, compaction capacity, material used and mixed proportions. It's necessary to select a concrete transportation method that makes it possible to transport concrete speedily and economically while by minimizing changes in workability and other properties due to segregation of concrete, changes in air content and slump. You have to take care now. A few minutes to me. You can read this. I'll be back and see what we can do now. It's no point to be serious about this issue. And then I'll be back again. Let us see how to do it. Let us see how to do it and how not to do it. That's the point here. we have to now think of again and see what is to be done in this case. I'll just bulk it up again so we can say how to do. And it is, concreting schedule we have to prepare, as I said. Concrete schedule we have to prepare. That schedule depends on many items as we discussed. Then we have to equipment, personal time to transportation, placement, finishing. We discussed that also. What type of model, capacity, what's capacity, and how many equipment necessary for transportation depending on quantity, frequency, and placement, and other tasks. And personal deployment means staff should be determined in view of such factors as conditions at construction site, type and shape of structure, transportation distance, concreting block size, quantity of concrete to be placed, in order of placing, rate of placing, availability of concrete, compaction capacity, materials use and mix proportions. All these make up a kind of concrete plan I have discussed many times, depending on what item, what element you pour. It's necessary to select concrete transportation method that makes it possible to transport concrete speedily and economically while minimizing changes in workability and other properties due to segregation of concrete, changes in air content, decreases in slump. On-site pumping on concrete, you can say on-site pumping of concrete greatly affects not only quality of hardened concrete but also pumpability and causes rate of placing higher than in other methods. On-site pumping of concrete greatly affects not only quality of hardened concrete. On-site pumping of concrete greatly affects not only quality of hardened concrete but also pumpability and causes a rate of placing higher than in all other methods. Therefore, it's important to draw up a well-balanced plan for a series of construction tasks. On-site pumping, therefore, requires prior studies on details such as concrete mix proportions, type and number of concrete pumps, pump locations, piping and pumping conditions. Surface finishing of newly placed concrete requires to be planned so that it can be carried out at an appropriate time, judging from various factors such as outdoor air temperature, humidity contents, solar radiations and other construction environment conditions, amount of bleeding of concrete, setting time, length of time after placement of concrete in each concreting block. If concreting blocks are large, work efficiency can be improved by using finishing equipment. Care should be taken, however, because surface finishing adjustments may be more difficult to make in machine finishing than in manual finishing. If concreting blocks are large, Work efficiency can be improved by using finishing equipment. Care should be taken, however, because surface finishing adjustments may be more difficult to make in machine finishing than in manual finishing. Transportation route. Transportation routes should be determined so that concrete can be transported easily, speedily, and smoothly, as well as transportation time and transportation distance be minimized. Concrete blocks, concreting blocks, joint locations, and construction joint treatment methods. Concreting blocks should be determined according to volume of concrete that can be placed in one day with reasonable effort after studying conditions. After studying conditions such as concrete supply capacity, construction schedule, shape of structure, placing capacity, allowable placement intervals, formwork and construction joints. You can list it that. What is to be studied? Concrete supply capacity, and that must be in line to frequency of trucks that can come. Then construction schedule means time for that object, that block. Shape of structures, what shape it is, and what is capacity we can place, that is important. And allowable placement interval, formwork and construction joints if required. Consideration should also be given to cracking due to heat generated by hydration. Cracking due to heat generation by hydration of cement. Autogenous shrinkage and drying shrinkage. If construction joints that are not indicated on design drawings are to be provided, if construction joints that are not indicated on design drawings are to be provided, location of construction joints. Location of construction joints and joints treatment methods required to be determined after careful consideration of such factors as structural performance of structure, durability and reinforcement patterns. Thus, it's important to determine concreting blocks, construction joint locations, and joint treatment methods in view of structural performance requirements, durability and cracking instead of solely on the basis of placeability of concrete, order and rate of concrete placement. Order and rate of concrete placement. Order and rate of placement in each concreting block must be determined in view of shape of structure, state of supply of concrete, placing capacity, allowable placement interval, organizational system for concrete placement, formwork or false work formation, etc., common practice when placing concrete in large concrete block is to begin at end far from source of concrete. Common practice when placing concrete in large concreting block is to begin at end from far from source of concrete space supply and at near end. In cases of certain types of structures, such as continuous girders and arches, placement of concrete may have adverse effects on previously placed concrete or change dimensions of completed structures because of formwork or falsework deformation. Order and rate of placement therefore must be determined, taking those possibilities into consideration. There were projects in which falsework collapsed because of careless placement of concrete. Order of placement requires to be determined so that loads on falsework can be distributed as evenly as possible. Quantity quality of fresh concrete is easily affected by not only time as mentioned but you can say also transportation method. In general, use of truck agitators is effective in maintaining slump and preventing segregation when transporting concrete from plant to construction site. In some cases, such as when volume of concrete being transported is small or when concrete is exposed to sunlight during transportation, amount of decrease in slump may be large. Methods of on-site transportation include concrete pump, bucket and chute methods. When a concrete pump is used, it's necessary to take into account slump and powder content settings, allowing for pumpability and decreases in slump during pumping as mentioned. Mixed design. In transportation by use of buckets which do not have an agitating function, there may be cases where changes in slump over time are larger than the changes assumed or vibration causes segregation. It's therefore necessary to select a transportation method so that required quality of concrete can be attained. Even in cases where mixed proportions are appropriate, if method of transportation, placement, compaction and finishing is not appropriate, segregation of concrete may result during whatever those tasks. During transportation, placement, compaction and finishing, concrete requires to be protected from sunlight and weather. It's also important to consider order of placement in order to prevent cold joints by placing concrete within allowable placement interval. Time for mixing to finishing placement. Time for mixing or completion of placement. Time for mixing to finishing of placement. Now, what to do with this? It's also very important point, and we have to be very careful about this. Time of placement. Again, I say we have here. This is my email ID. Again, I just telling again Suraj_engineer at yahoo.co.uk, and here is my international professional engineer certificate, and this is quality file, coordination file in concrete. As a standard, time from completion of mixing to completion of placement should be 2 hours or less, or 1.5 hours or less. Outdoor air temperature is 25 degrees or lower or higher, 25 degrees respectively. Means it's generally 2 hours when temperature is up to 25 degrees, and it's 2.5 hours when temperature rises above 25 degrees. Since quality of fresh concrete changes over time after completion of mixing, it's desirable that transportation, placement and compaction be completed as soon as possible. In concreting work, however, it's often not possible to complete placement of concrete in a short time after it is mixed because of transportation related constraints concerning available plants, available transportation routes, location of structure, and placement, as well as compaction related constraints concerning shape of structures, reinforcement patterns, and available personnel and equipment, etc. It's therefore important to perform planning and management, taking those constraints into consideration so that various tasks can be smoothly carried out within scheduled time frames, and to check in advance on changes in quality of fresh concrete over time, because limit of time within which placement of concrete can be completed after completion of mixing varies depending on conditions such as concrete mix, proportions, materials used, temperature, humidity, and transportation methods. Good practice is to set a limit suitable for each concreting work in view of these conditions. In general, time limit is about 2 hours at or below 25 degrees Celsius and 1.5 hours when outdoor air temperature is higher than 25 degrees Celsius. These limits therefore are specified. If minimum slump for placement cannot be achieved by time placement of concrete is completed, it is necessary to take measures such as considering use of construction method for completing task in a shorter time than specified standard time, modifying mix proportion so as to reduce changes in slump over time, or increasing slump upon completion of mixing. An effective method for reducing changes in slump over time is to use a chemical admixture that excels in slump retention, such as an air and draining high range water reducing agent. If slump upon completion of mixing is to be increased, it is advisable to consider a switch to a chemical admixture that functions as an effective water reducer, such as an air entrainer high range water reducing agent, because water content tends to increase if slump upon completion of mixing is increased. When taking these measures, it is necessary to conduct studies on those measures well in advance to verify effectiveness. Transportation. Transportation. Transportation to construction site. In cases where ready-mix concrete is used, we can say regarding transportation shall be followed whatever provisions are there. In cases other than those mentioned, shall be ascertained that transportation method used permits easy unloading, causes little segregation during transportation, and minimizes changes in slump air content. Ready-mix concrete specifies performance of transportation vehicles and requires that, as a general rule, process from mixing to unloading be completed within 1.5 hours. Since, however, this specification requires that outdoor temperature is higher than 25 degrees Celsius after completion of mixing, placement concrete as a general rule be completed within 1.5 hours. It's recommended that transportation from plant to construction site be completed in about 1 hour. If transportation distance is long or slump of concrete is large, truck mixers with an agitation function or truck agitators must be used for transportation. In cases where concrete with a slump of 5 cm or 50 mm or less is transported over a distance of 10 kilometers, or such concrete can be transported within 1 hour. If transportation distance is long or slump of concrete is large, truck mixers with an agitator function or truck agitators must be used for transportation. In cases where concrete with a slump of 5 cm or less is transported over a distance of 10 kilometers or less, or such concrete can be transported within 1 hour. Method of using dump trucks or dumpers or buckets loaded on automobiles may be used after ascertaining that segregation does not occur and changes in slump or air content etc. are small. In cases where there exists an empirical knowledge about combinations of concrete quality and transportation methods, it's necessary to conduct tests under realistic conditions to determine influence on changes into quality concrete. On-site transportation, and that's concrete pump. Have to see concrete pump. Prior to pumping of concrete, details such as type of concrete pump, pipe diameter, pipe roots, and discharge rate be determined, taking pumpability of concrete into a consideration so that concrete of required quality can be obtained. Pipe diameter shall be selected in view of type and quality of concrete. Maximum size of coarse aggregate, pumping conditions. Type of concrete pump, pipe diameter, piping route and discharge rate shall be determined, taking pumpability of concrete into our consideration so that concrete of required quality can be obtained. Pipe diameter shall be selected in view of type and quality of concrete. Maximum size of coarse aggregate, pumping conditions, ease of pumping, safety, etc. So that pumping capacity is sufficiently large. It's desirable that concrete pump locations and piping routes should be determined so that piping distance and number of bends are minimum. Type and number of concrete pump. Type and number of concrete pumps shall be determined in view of pumping load, discharge rate, rate of placement, and environmental conditions at job. Type and number of concrete pumps shall be determined in view of pumping load, discharge rate, rate of placement, and environmental conditions at job site. If difficulty in pumping is expected, test pumping shall be conducted in advance to check on pumpability and quality of concrete. It's recommended that prior to pumping of concrete, mortar with a mix of proportion equivalent to that of mortar and concrete should be pumped so that more sticks to inside surfaces of concrete hopper and piping. As a general rule, however, mortar should not be pumped into formwork. It is recommended that prior to pumping, mortar with a mixed proportion equivalent to that of concrete should be pumped so that mortar sticks to inside surfaces of concrete hopper and piping. As a general rule, however, mortar should not be pumped into formwork. Pumping shall be planned and controlled so that pumping can be carried out as continuously as possible. When pumping needs to be interrupted for a long period of time, appropriate measures shall be taken so that pumpability and quality of concrete are not lost after pumping is resumed. Control to be pumped in must have control. Concrete to be pumped must have pumpability suitable for pumping. Concrete to be pumped must have controllability. You know, concrete to be pumped must have pumpability suitable for pumping. Just like we say constructability, here we call it pumpability, which should be suitable for pumping. This specification therefore provides for mix requirements such as powder content, mix design and requires a slump be determined taking into account changes over time and decreases due to pumping prior to pumping of concrete. Type, locations and number of concrete pumps, piping routes and diameter and type of pipe discharge rates, etc., must be determined appropriately so that assumed conditions are met. Prior to pumping of concrete, type, locations, and number of concrete pumps, piping routes, diameter and type of pipe, discharge routes, etc. must be determined appropriately. So there's just a point here, concrete to be pumped must have pumpability suitable for pumping. This specification therefore provides for mix requirements such as powder content, mix design, and requires slump to be determined taking into account changes over time and decreases due to pumping prior to pumping of concrete type, location, and number of concrete pumps, piping routes, diameter, and type of pipes. Discharge rates must be determined appropriately so that assumed conditions are met. It's also important that not only slump but also air content, unit mass, temperature, etc. of pumped concrete be within required ranges. If changes in quality of pumped concrete fall outside expected ranges, it is necessary to reconsider concrete mixer versions, slump, the pumping, some pumping. It's also important not only slump but also air content or unit mass, temperature, etc. of pumped concrete be within required ranges. If changes in quality of pumped concrete fall outside expected ranges, it is necessary to reconsider concrete mix proportion, slump pumping methods, etc., and take appropriate measures. For matters not described in this section, recommendations of placement of concrete pumping should be consulted. Piping diameter should be determined after considering maximum size of coarse aggregate, amount of pumping load. Pipe diameter increases, as pipe diameter increases, pumping load decreases. Unit of large diameter pipes therefore is desirable. Use of large diameter pipe therefore is desirable, but it's recommended that pipe diameter be determined in view of fact that large diameter pipes lower efficiency of work association. Okay, then that's also important. In concrete pumping pipes with nominal diameter of 100 ampere, or in concrete pumping pipes of nominal diameter 100A or 125A are used in many cases. In large scale construction, 150A pipes may be used. In general, pipe used with a nominal diameter of 100A can be used in cases where maximum size of coarse aggregate is 25 mm or less and piping distance is relatively short. Nominal diameter here refers to inside diameter of pipe expressed in millimeters and inches. For example, 100A 4B means an inside diameter of about 100 mm or about 4 inches. So we say, for example, 100A means an inside diameter or about 100 mm or 4 inches in order to reduce in order to reduce in order to reduce overall pumping load and prevent clogging of piping, it is desirable that concrete pump locations and piping routes be determined so that piping distance and number of bends in piping are minimized. Pipe sections near bent or tapered pipe sections are are particularly subject to flow velocity fluctuations, pressure loss and clogging. Good practice, therefore, is to use bent pipes with large radius of curvature and gently tapered pipes. In order to perform stable pumping, it is necessary to inspect pipes for deposits on their inside surfaces, wear, etc., and consider vehicle allocation methods for smoothly supplying concrete, from transportation vehicles to concrete pumps, and methods for facilitating tasks such as assembling pipes for pumping, washing, and inside surfaces of pipes after pumping, and moving and removing pipes. Pipes for working platforms need to be selected so that pump work, reinforcement, and previously placed concrete are not adversely affected by vibration and loads from pipes during pumping operations. Selection of type of concrete pump is the most important item. Selection of type of concrete pump is most important item for carrying out placement of concrete with pump smoothly. Maximum pumping load on concrete pump Pmax can be established on basis of result in similar type of construction site or one from preliminary pumping test. However, in general, Pmax is calculated by using a following equation. Type of concrete pump is selected in a manner that calculated maximum pumping yard, calculating, same restraints. So calculating using analysis, as you can say, when channel Pmax is calculated by using the following equation, then types of concrete pump is selected in a manner that calculated maximum pumping load is not more than 80% of pump capacity. It says selecting manner that calculated maximum pumping load is not more than 80% of pump capacity. If some restraints may exist in size of setting yard, size and dimensions are also decisive. Conditions for selecting pumps are type. Pmax is load and pressure per 1 meter length of horizontal pipe. Load and pressure per 1 meter length of horizontal pipe multiplied by equivalent horizontal pipe pumping distance. It says, however, in general, Pmax is calculated by using a following equation. Then type of concrete pump selected in the manner calculate maximum pumping load is no more than 80% of pumping capacity. If some restraint may exist in the size of setting yard, size and dimension are also decisive conditions for selecting pump type. So here is formula. Pmax is equal to loss in pressure per 1 meter of horizontal pipe into equivalent horizontal pumping distance. Pressure loss per 1 meter length of each horizontal pipe can be decided by using data of type and quality of cement, rate of rate of pumping, diameter of root pipe and diameter of pipe, and loss is largely with smaller value of sump. Now, pressure loss per 1 meter length of horizontal pipe can be decided by using data of type and quality of cement, rate of pumping, diameter of pipe, and loss is larger with smaller value of slump, smaller value of transportation pipes, and larger rate of pumping. So it's very value of loss in pressure in case of concrete using 20 to 25 mm of maximum size of coarse aggregate. When using coarse aggregate having 40 mm of maximum size, values should be increased 10% from values shown here as for equivalent horizontal pipe length for each type of pump pipe, just for calculating equivalent horizontal pipe distance. Now, that is the standard value of loss in pressure, that is rate of pumping, and it is loss of pressure versus standard value of loss in pressure. Maximum size of coarse aggregate 20 to corresponding 25, cement content about 300 kilogram per meter cube, air entering water reducing agent used. So what it says, let us see this how it works. Rate of pumping meter cube per hour, loss of pressure in pipe. In this case, slump is 8 inch and slump is this is 8 centimeter, and this is where there is 1 star, it is 8 centimeters, 12 centimeter here. So what it says is this dotted line is for 100, a with one wild character. You can say here is 150 diameter pipe. It's also 150 diameter pipe. You can see here is loss of pressure in pipe is less here, and here it is 100 A pipe 2 and 1 star. Loss is more here. In 125 loss is lesser, and in 150 it's lowest. It is up to rate of pumping in meter cube per hour, and loss of pressure in pipe is 10 minus 1 Newton per meter hour. Table equivalent horizontal pipe length. Horizontal pipe length. That might also we have to be very clear about pipe length and how much is that. Let's be clear about that first of all. Let me choose something here again. Suraj_engineer@yahoo.co.uk. My certification and quality file, conditional file, concrete file. That is equivalent horizontal type, horizontal pipe length. Here this columns of item, unit, nominal diameter of pipe, and equivalent horizontal pipe. You can say item, unit, nominal pipe, diameter, equivalent horizontal pipe, equivalent horizontal pipe length. The cases of vertical pipe, tapered pipe, bent pipe, and flexible hose. Item 1, vertical pipe. Unit is 1 meter, that is equivalent horizontal pipe length. Nominal diameter 100, 125, 150, 4 inch, 5 inch and 6 inch. Band you may say. Equivalent horizontal pipe length is 3 meters, 3 meters and 5 meters, 3 meters, 4 meters, 5 meters. Okay, so we say vertical pipe is 1 meter and diameters are 100, 125, and equivalent horizontal pipe in length, that is 100 diameter is 3, 125 is 4, 150 is 5, equivalent horizontal pipe. So 150 is 5, this goes on increasing per diameter. So equivalent horizontal pipe length, say pipe length is 100 mm, for 100 it is 3, for 125 is 4, and for 150 it's 5. Tapered pipe, it is one piece, and that is 175, 150, 125, and this is reverse direction. This was greater than 150, it's greater than 125, and this is 3. That's what it says. So flexible hose 5 to 8 meters in one piece, that is 20 length. And here bent pipe is one piece, 90 degrees radius, and that is 0.5 meter. R is equal to 1 meter. And therefore is total is 20. No, one piece is 20 here. Flexible hose is 20. Value for pumping of normal concrete, that is single wild card, and double wild card is value for tapered pipe with 1 meter of length as standard and established one on basis diameter and smaller pipe. We have one that is you can say volumetric efficiency. Volumetric efficiency of a pump varies depending on concrete mix proportions. Properties of fresh concrete and actual discharge rate is smaller than theoretical discharge rate. Since rate of placement in construction plan is average rate of placement, work including such tasks as moving pipe and compacting concrete, actual discharge rate is higher than rate of placement. Discharge rate assumed for calculation purposes therefore must be value reflecting volumetric efficiency rate, volumetric efficiency of pump and work efficiency. It is necessary to draw up a plan so that pumping can be performed smoothly even at that discharge rate. Number of concrete pumps is determined in view of rate of pump, discharge rate for type of pump or pump to be used. Means discharge rate for type of pump to be used, size of concreting blocks, volume of concrete to be placed and you can say replaced, order of placement, rate of placement, state of supply of concrete, compaction capacity, number of placing locations, etc. For concreting work that requires continuous placement of I again say it's volumetric efficiency as well, please. Volumetric efficiency of a pump varies depending on concrete mix proportions, the properties of fresh concrete, and actual discharge rate is smaller than theoretical discharge rate. Since the rate of placement in construction plan is average rate of placement, work including such tasks as moving pipe and compacting concrete, actual discharge rate is higher than rate of placement. Discharge rate assumed for calculation purposes therefore must be value reflecting volumetric efficiency of pump and work efficiency, and it's necessary to draw up a plan so that pumping can be performed smoothly even at discharge rate. Number of concrete pumps is determined in view of rate of pumping, discharge rate for type of pump to be used, size of concreting block, volume of concrete to be placed, order of placement, rate of placement, state of supply of concrete, compaction capacity. So what we say here, discharge rate assumed for calculation purposes therefore must be value reflecting volumetric efficiency of pump and work efficiency, and it's necessary to drop a plan so that pumping can be performed smoothly even at discharge rate. Number of concrete pumps, etc. we have to see before, we have to do accordingly. Number of pumps, how many should be there, number of transit mixers, the frequency of transit mixers, and how to locate and relocate your pumps positions, your transit mix positions, so that all area where concrete goes on has to be covered properly. And that means the number of concrete pumps is determined in view of rate of pumping, discharge rate for type of pump to be used, size of concreting blocks, volume of concrete to be placed, and order of placement, rate of placement, and whatever else You can say placement, state of supply of concrete, compaction capacity, number of placing locations for concreting works that requires continuous placement of concrete. Good practice to prepare backup concrete pumps. That's very important, backup concrete pumps. If difficulty is expected in pumping of concrete, it's necessary to check functioning of concrete pumps, pumping loads, condition of discharged concrete by taking appropriate measures in advance, such as conducting test pumping under realistic piping conditions. Pressure losses in pipes and changes in quality of concrete due to pumping are largely unknown because these vary depending on type of concrete used. So we have taken, I think, 2 days. So we have say here taken into considerations about these talks. In fact, we have to see we have gone through certain requirements of concrete, difficulties expected in pumping of concrete. It is necessary to check functioning of concrete pumps, pumping loads, conditions of discharged concrete by taking appropriate measures in advance, such as conducting test pumping under realistic piping conditions, pressure losses in pipes and changes in quality of concrete due to pumping are largely unknown. We'll take up this later on. Now, issues real quality engineering and reliable coordination engineering. This talk which I am making for concrete here is same as related to this one, real quality engineering and reliable coordination engineering, and also we can say manufacturing construction procedures. That's what we are talking of, and continuously to do assessment of works and quality goals in all works we are talking of here. And that's why it's also called missing real coordination, means missing good engineering is also a kind of coordination construction, and that's what we're talking of here. We have to understand these points: quality construction and its construction, and we call it reliability quality engineering works deliveries. Reliable coordination engineering is a must, a professional engineering not for all. And obviously reliable coordination engineering and projects, and here we talk of engineers can handle both, and that's an important point. Real quality, we can say there is real quality and domain, real coordination, which we concentrate on, without which we cannot move, and that point we have to understand. We have to understand that point clearly, effectively, so that we know where we have to go, what we have to do, and that's really important point. We have to understand clearly. We have gone through this session. To other issues, buckets, we have to discuss buckets, then chutes, then other transportation equipment, that is pneumatic concrete pacer. We have here wheelbarrows, belt conveyors, wheelbarrows, then placement, what to do with that, and placement continues here around time level. So many technical points are involved on this, and compaction we have to do in details, finishing, correction of surface, and we have to do this. Chapter curing will come, so we'll see how can best we move. Those areas we have gone through, and that is important point. Page 164 something, I think it's this one, and we have to see, we have to stand here on page 164 and see. You can say that I take your leave now. It's better. I'm ending this. I hope you got importance and got some information from this. How can work be improved on site, particularly concrete work, concrete which is main work on sites, on construction. It's question of concrete material design, concrete theory, concrete technology. You have to understand and to do accordingly. Otherwise, it's next to impossible that we can do something. Otherwise, your concrete goes waste if you don't control on quality. Concrete quality is very important matter, very important, because it is on site manufacturing. Batching plant is also a part of site. it's manufactured on site, and we have to take care about that. And I think with this approach, I understand that this type of talks are very useful. Maybe you people not realize at this stage, but you work in field, you shall find that this is very important, because these items are not so easy as we think these are, as designers do think these are. But designers also should know all this, and that's the reason I am inclined to involve myself a lot of timings on such methods. Designers are also responsible for quality of concrete. It's not system alone. Designer is a part of system. Designer is a part of site, because it is a designed site. It has to work accordingly. Nothing can be said otherwise. Engineering construction particularly is very difficult. If we count for that, and if we don't worry about this, in that case we make mistake, I can say. We have to think over this many times. It's not simply engineering design is enough. Concrete design, concrete capability, concrete consistency, concrete competency, concrete construction, concrete involving from mixing plant to finishing a time. These are very important points that we should not miss. We have to understand them very, very clearly. Only then we can say something can be brought into our understanding. It's not even easy to understand, because it's completely non-mathematical talk. Mathematical and numericals are not involved in this, and that's why people feel sometimes it's boring. In fact, engineers feel this is boring and we have to be a little different. Boring or not boring, we cannot avoid concrete. I sometimes feel very angry when I see concrete that's ongoing somewhere here and there. And you hate that concrete. What nonsense these people are. They don't understand anything. They just do concrete for sake of mechanical work only. They just want to make something and pour in, and they use all rusted steel and all that. But if you go into in details of concrete technology, you'll find a lot of interesting information available that I got by chance. Japan specifically. It doesn't matter, you should stick to Japan. You can discover, you can download other informations also, there's no harm. You can download American, you can download European or English or whatever. We have to be very serious about that issue, and that's why I tried this one for you people. I take your leave now, and we'll see next time what to how to do. Thank you very much.